must be magnetic in some sort, and in some sort of way. And if it's not, there's a very specific reason why it's not magnetic. So here's an example.
You might not think of water as being magnetic, but it is. And so are graphite, aluminum, and glass. Aluminum is a good example of a paramagnet. And so is oxygen, which is attracted to magnets. Here, I have a few milliliters of liquid oxygen, which sticks to the magnet. I'll explain why later. Gadolinium oxide and cupric sulfate are good examples of paramagnetic substances. Cupric sulfate is a salt that can be picked up by a magnet.
Here is a picture of an electron. There's a picture taken about a decade ago. They tell us that this is a light beam or electron riding a light beam. Can you see a particle anywhere in this picture? No, there's no particle. They're resonant waves, and yet they tell us it's an electron. Can you see how we get brainwashed? So this is what Nikola Tesla has to say about the electron from an interview in 1928. On the whole subject of matter, in fact, Dr. Tesla holds the view that are startlingly original. He disagrees with the concept of atomic theory of matter and does not believe in the existence of an electron as pictured by science. So it's a shock to the system, because we all think electrons are low, electrons are low. And you start seeing an agenda being developed here, an agenda being developed by mainstream universities, the mainstream scientific fraternity, under the guidance of those that are trying to lie to us and make us believe things that are not so. This is what Einstein has to say about the electrons. In the theoretical treatment of these electrons, we are faced with the difficulty that electrodynamic theory itself is unable to give an account of their nature. For since electrical masses constituting the electron would necessarily be scattered under the influence of their mutual repulsion unless there are forces of another kind operating between them, the nature of which has hitherto remained obscure to us. So he says, he doesn't quite understand how electrons come into being. And he tells
Okay, now we're going to go through and talk about electromagnetic induction. If you have an electromagnetic current, it actually defies gravity.
In August 1831, Faraday wrapped 2 coils of insulated wire around this iron ring. The investment paid off. When Faraday connected a battery to one of the coils, he saw a brief pulse of current in the other coil. And when he disconnected the battery, he saw a pulse of current in the other direction. He realized that current was induced in the second coil only when the magnetic field through it was changing. And if they hadn't been wrapped on the same ring, Faraday may have noticed that the 2 coils repel each other when the current is induced, and that's due to the interaction of their magnetic fields. Which brings us back to this. Through the bottom coil, we are passing a huge electric current, 800 amps, which alternates in direction 900 times per second. This ensures there will always be a changing magnetic field above the coil. Instead of a second coil, we're using the aluminum plate, but the principle is the same. The changing magnetic field induces currents in the plate that create an opposing magnetic field, so it levitates.
How awesome is that?
This current is not only good for levitating the plate, it can also make light bulbs glow.
Oh, thank you. Oh.
A lot of people ask, how can the sun and the moon go around the flat earth and the stars? Well, everything is ran by electromagnetics, okay? So they would levitate above the earth. They don't have to be circling around the sun at all. You don't need the sun to be in the center of the universe, okay? You can easily have everything you need right here on Earth, because Earth is an electromagnetic conductor.